Hello and welcome. I don't think anyone's watching tonight, so I might start a couple of minutes early. Um, Hopefully, people can catch up as they do join. Yeah, welcome to the last me learning Haskell and live streaming it of this year. I'm not going to bother doing it next week, which is the final date I could do it. So tonight, I just want to write some code and have a bit of fun. I'm going to look at Advent of Code again. I'll try and pick something that's reasonably easy, as easy as I can find, I guess, and just enjoy writing some code. Last week I did day 12. I still haven't finished it. I kind of got nerd-sniped by it a little bit. I spent quite a lot of time, not quite a lot, yeah, a fair amount of time actually, playing with Haskell and trying to understand laziness in a bit more detail, and trying to understand how full-dem works, particularly with lazy evaluation. And just trying to optimize things a little bit, and also trying to learn how to trace things, and then maybe look a little bit at memory usage and so on. So it's been kind of interesting, but I haven't actually finished the exercise. So hopefully today I can find something that's a little bit shorter, won't lead me down some rabbit holes, and I can finish it in an hour, or finish some of it in an hour. So let's get started. I'm going to pick up, let's start with day 13, see what it looks like. Oh, it's more hill climbing. Okay, so what does this look like it's going to be? I basically don't want to go down another Dijkstra style shortest path route, but hopefully we can find something a bit different. Okay, we get a distress signal, and it's out of order. We need to reorder it. Hey Tim, welcome. Sorry I started early, but hopefully you can. Well, I just started. Basically, I've just opened this. So I need to reorder the list of received packets. It contains pairs of packets and is separated by a blank line. You need to identify how many pairs in the right order. Okay, so here's pair of packets. May or may not be in the right order, I guess. Ooh, many brackets. Packet data consists of lists and integers. Each list starts with an open bracket and ends with a closed bracket. Contains 0 or more comma separated values, either ints or other lists. Each packet is always a list and appears in its own line. Okay. Comparing two values, first is left, so top is left and bottom is right. If they are both integers, the lower integer should come first. Okay, so we don't really have an example of that. The left integer is lower than the right, the inputs are in the right order. If the left integer is higher than the right, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. So here, for example, I guess they're the same, so we keep going. If they're both lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. So just cases where this is shorter, I guess. If the list is the same length and no comparison makes a decision about order, continue checking. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value. Then retry the comparison. So if we're comparing the list 0, 0, 0 and 2, we convert that to 2, and then we get 0, 0, 0 and 2, where I guess these all apply. So we check the 2 against the 0, and the 0 is a lower integer, so that's correct. And however, the left list does not run out of items before the right list. Okay. So this is numbers easy to compare. lists, so we compare the lists of the first ones. Then we can compare the list containing 2, 3, 4 to the number 4, so we convert number 4 to a list, and then we compare it. We compare 2 and 4, and the left side is smaller. Always say we only continue checking if they're the same. Okay, so we don't care about the 2, 3, 4, sorry, the 3, 4 here. Okay, and so on. Let's see if we can make a start on this at least. What day is this? Day 13. Editor. Okay. Cabal run new day 13. Okay, and then we should have day 13 part 1. Just wait for language server. Okay, cool. And in here as well, I'm going to put test input. This stuff I just copied, I think. Yep. Okay. So first of all, we have lists, which are either a list, or, well, the items in the list are either a list or an integer. And this is going to have some int value. I can't call it integer because that's already a type. I'm going to call it L integer. Actually, I might just call it number. Let's call it number. Because I don't think that's a type already. Maybe list or a number. And then we want to write some kind of parser which will take our input, which is let's take the whole string for a second, and we're going to return a list. We're going to return 2 lists, a left and a right. So we want to break it where we get a double blank line. So we can say break on, and then we'll give it, not like that, we'll give it 2 blank lines. And then I need to define break on, because I don't think, there's something in data list extra or data list split which will do this for me, and I might just use it. So we have, what have we got? We've got a list of A's and another list of A's, and we want to give us back a list of A's, split on from the split package. Okay. Oops. So let's go back to the compile file. Day 13 will also depend on, split is available in the base package. Good to go. Seems happy enough. So you can say split on, a couple of blank lines, and S. And we can import that. Cool. And we'll add to reduce it just for fun. And here we can just say show the parsing. Now we're not returning lists of lists at the minute, so let's just comment this out, and we will return a list of strings. Just make sure that we've got the right, that we chunked it correctly. We're going to have sort of trailing blank lines and stuff like that. So we say, cabal run not K, but day 13, pipe in day 13 / test input. Okay, this is cool. So this is our right and left, right and left. So we now need to take this input and then we can split it on new lines, or just call lines on it basically to split those up. So we can turn this into pairs. I won't necessarily turn them into pairs, actually, just turn them to lists again. So we can go lists of strings by running lines over the output of that. We cannot. Let's try it like that. No, that wasn't the problem. Oh, so we need to map lines over it. No. Map lines, split on that. Oh, come on. Map lines over the output of splitting on. I'll get it eventually. Okay, now we have a list containing left and right, another one containing left and right. I could turn them into integers, but I can just compare them as strings. That should be good as well. But we can still turn them into this list of lists, I think. A pair of lists. So it's an array of pairs of lists. Okay. So we have our lines, and then we need to parse that into a list. So we can say parse list. Actually, let's do parse lists over that. Oh, every time it defaults indenting by 4 spaces. I need to work out how to change this. Okay, where? Parse lists takes list of lists, list of strings, sorry. And I need a dot in there, sorry. And it's going to return to me a pair of lists. I'm going to say parse lists is equal to, okay, I'm going to do some pattern matching here. So if we have X and Y, then I'll deal with that in a second. Because that's what we want. It's not actually X and Y, it's X colon Y colon empty list, and then I can do it as a literal. So I can do it like this. Okay, so that's the form we want, where we have 2 lists, left and right. But I can also say parse lists of anything else is an error. Let's grab it for a second. It's going to be an error where we say unexpected input SL. Sure will. Okay. So when we have a left and right, what are we going to do? We're going to parse these things individually. So we're going to return parse list X and parse list Y. I'm going to rename this actually. I'm going to call them left and right. So left and right. Left and right. Now I'm going to try and be good and not reach for megaparsec. So what I'm going to do Maybe I just want megaparsec or some kind of parser. It'd make it a lot quicker, but it feels like cheating. It actually feels like I go on a long detour looking at how to use megaparsec again rather than just getting on with solving the thing. Don't know what's going to be easier. Parse list takes a string and produces a list. Okay, so I can do sort of things like checking to see if it's an opening bracket. Checking to see if it's a number. But the number's easy, right? You can say yeah, let's start with this. So we've got x and x's, where is digit x, and then we can say this is a number of read x. Can't read x like that. Also got to make sure that these are single digits. They are not single digits. Okay, so we need to parse the whole number. Okay, so let's reach for a parser. Negative parsec means we might get rid of split as well. So let's import where is it? Data.parser, data text.megaparsec. Doesn't seem to be there. Text.megaparsec. Okay. And then we can say that our parser, so we can say a list parser, type of list parser is parser, I can't remember how this works. Is parsec a type? Apparently it is. Can I get info about the type? I cannot. I think most of these videos are me looking up how to use megaparsec. Skip to readme. Yeah. Tutorial. Just go with it. Oh, just an example. So our parser is parsec void text. In our case, it's going to be parsec void string. I can just call it parser, that's nice. So it's parsec void string. I need to put data void. Actually, I can just import void from there. Let's get rid of that second. I still think we want to parse into this type. But here we can say something like parse number is going to be something of type parser int. And then I can't remember what the helper is for that, but it's Zoom in a bit from that. Let me duplicates tab, and we'll go back, and we will look at megaparsec char. So there's something like digits. Digit character, and then you can say many digit characters, something like that. Can we just say many digit character? Nope. Can we say read? We cannot. Can we say read result of that? Yes, we can. Okay. That should give us numbers back. And then we can say parse list. Parser gives us back a list. Parse list is, and then there's something like between. Where would I find between? Not in here. Okay. I might need to jump into the lecture for that. Space lexeme symbol. Got the indentation levels. Nope. This is not the thing I want. Okay. Somewhere in here, there's a thing for running between. Not a choice. No. There was something for brackets. Yeah, there's a helper called between. So why can I not use it? So between a character called, not called, but that character, basically. And, whoops, that character. What to do with that? What does between actually do? Illegal type that. Does character type that? No. What's happening there? So, oh, I've lost what it said between. Between character in single quotes and then that. Bit confused here. So what's the type of between? No suggestions. Duplicate signature parse list. Where's the other signature? Oh, sorry, I've said colon between. It should be parse list equals, right, between that character and this character and then what's the filter interval between? Takes open, close, and then I think the thing that we're going to parse, we say parse list. Don't know if that's a jet. That's problematic because we actually need a list has got something inside it, and parse list contents goes from a parser, and it's gonna be, well, lists contain other lists. So parse list contents is going to be parse list or parse number. Okay, so this doesn't work now, so we need to not return an int, but we need to return a list. But here we're going to say number applied to that. Doesn't work. Number.read applied to that. Okay. And this is going to say list of that. Apparently not. Okay, I don't think this is going to work. Probably export this. We don't need split on anymore. We will export our parse list. We haven't used a data constructor, and the fact we haven't used this worries me because I've never told it it's a list. So this feels a bit wrong. I wonder what this should be, and this should be. So for a list, we expect an opening and a closing. Maybe parse list contents. And what if it's nothing? Let's just see what does work. And it's 13. Yeah, nothing's going to work. Okay. So can we say parse and then our, oh, what's the type of parse again? Import text.megaparsec type of parse. So it takes the parser first, then it takes an input string, and then the file name until it goes back. So parse, use parse list. Our input string is going to be the number 1. Are the commas separated as well? Actually, need to look at that in a second. Our input file is empty. Part 1.parse list. And I'm going to show it. No instance for that. Okay. Deriving show. Reload. Okay. Import that. Import. Oops. Part 1. Okay, so it's an error of some kind. Does parse test give me some more helpful output? What does this take? It takes parsec and an S. So the parser and the input string, and gives me back number 1. Okay. We just pass it on its own. You get nothing. Okay. So let's quickly look at our input from before. The input is comma separated. Okay, so the definition of a list is either nothing, so it's an empty list. We have a case here. Or it's an item, so either another list or a number, separated by a comma. So is there a way in make a parsec parsing nothing? There must be, right? Primitive parsers. Sorry, primitive combinators. EOF, it's not really the input. It's kind of just a nothing. Okay, let me look in, where would it be? Megaparsec. The character's not going to have anything, is it? End of line, space, blah, blah, blah. Nope. Those are re-export. Winner combinators, summon many. Don't think any of these are what I want. Empty. This parser fails unconditionally without providing information about the cause of the failure. We don't want that. I guess actually many works. Or it's like a 0 or 1. Option. Well, separated by comma is quite useful. 0 or more occurrences separated by a comma. Actually, that's what we want. Okay. So something separated by a comma. So it's this. Oops. Set by comma. Okay, many things are wrong here. So couldn't match type list of lists with single list. So we can say that this is a list. So we can put this constructor back in again. This doesn't take an argument here, but it should do. I guess we need the empty list as well. What's coming to types here? So this thing will give me back a list of lists, possibly empty. Okay, so I'll just import comma. I will not. Where does comma come from? I thought it would come from here. Wow, okay. The character, comma. Okay, so now a list can contain many inner lists. And then if I say list here, it does not work. Because I need to apply it to the output of that parser, not the parser itself. Okay. Reload. Where have we got? Let's import that. Import part 1. And then we can say parse test, parse list, number 1. Oops. He's got a list containing number 1. Okay. The numbers 1, 2, and 3. Well, that's good. 1, 2, and then list containing 3. Good. And then the empty list. Not quite. Exception, please read no parts. So we're close. I've said it has to be a list or a number. So we're back to the empty problem. So we can say it's that, or it's an empty list. It's a bit dubious. Might work just about enough for this this test. No, it still thinks it's a number. Okay, I'm going to move that into my list of options. So it's a list. Into here. Can I say pure empty list in this point? I don't think so. There's no nothing, is there? I kind of want to say what do I want to say? Annoyingly, it's spotting it's a list. It's spotting the inner thing is not a list. Maybe it works if I have a list of lists. Containing number 1. Whoops. Yeah, that's okay. But if the thing inside is an empty list, it says it's not a list, so therefore it tries a number. And I want like a kind of, it might be list, it might be number, or it might just be empty. I don't know how I specify empty. Because this is supposed to be 0 more occurrences separated by sep. But I think it's to do with the choice I gave it. Oh, go forward. At the top of this file. And let's say work with alternatives. That's no good because we expect it to not be there. We could say option, I guess. So option empty list. But that's the same as P or pure X, which is pretty much what I was saying before. And this turns maybe. I don't really want it to fail. I'm going to try just putting empty in and see what happens. What's it saying? Right identity. Why not put the right identity in? Okay. So I was fearing that I'm going to spend my time arguing with megaparsec. There's some option set by I'm going to try option. So it doesn't feel like this would work, but we can say option empty list of that. Port text.megaparsec import part 1. Still trying to parse as a number. Okay. we got something about trying things? So we could try this or something else. Okay. So we could try some content. Or the empty list where some content is equal to that. Probably still not going to work. Nope. Oh, this is annoying. How do you parse nothing? Well, why is it not letting me parse nothing? Because it, like, the set by is supposed to parse 0 or more in terms of list of values returned by p, which should be an empty list, I would have thought, if it can't parse them. I mean, try doesn't really make sense here to me. So we'll parse list, we'll try the number. Yeah, I want to make it safe for the number to fail. I know what it is. I think I know what it is, actually. I think. So many can match 0 digits. I think it should be some. Because I think what was happening is reading no digits and then trying to convert it back to an integer. Yes, okay, that's good. So we can go 1, 2, and then empty list, and then a list containing 3. So a list containing number 1, number 2, an empty list, and a list containing number 3. Okay, cool. Right, we have a parser for a single list. Right, so what we then want to do is we want to parse pairs of lists. So we can parse pairs of input. And this should give us a pair of lists. So parse pairs is, and what do we do here? We're going to just return the tuple operator applied to, it doesn't seem right, parse list followed by parse list. Okay, interesting. It type checked. Okay, we'll try that. Reload. Make a parsec. Oh, we're not quite right. So we need to consume the new line. So we parse a list. And then no, that one. And then we have new line, EOL. Reload. Make a parsec, part one. So it's parse pairs, I think it called it. Okay, expect a new line at that point. So we can say, give it a new line and then another list. Cool, that seemed to work. That was easier than I thought. Okay, so now we've got parse input. Actually, this is parsing a single pair and all the pairs. Which is a list of pairs of lists. So to parse pairs, what do? This is going to be, I think it's going to be parse a single pair separated by, and then the string multiple new line. And we can pull that in. So now we can say it'll be show of parse pairs. Mess that up. Parse pairs. We want show s of s and then the empty string, and this should now be $. Okay, so we'll try parsing all the pairs and we'll just see what it gives us. I'm hoping for right and then some lists of lists. Some lists of pairs of lists. Not exactly. Right, but nothing, so it thought everything was empty. So what's the first line? Should get these two and then two new lines and then these two. Still exporting, aren't we? Yeah. What we could do is always eat the end of line here, throw it away. Then we're only separated by end of line at this point. Very pedantic. Okay, so we'll import text and make a parsec again. We will import part one, and we can say parse test, parse pairs, and we give it a string, so it was something like a list containing 1 and 2. It's good enough. Followed by a new line, followed by, let's have an empty list for no particular reason, followed by a new line. So that works. Single pair is okay. have another blank line, and then we'll have another list. So we'll have 3 or 2 and 3. Doesn't matter what they are. And then a new line, and then another list with, let's say, 4 and 5, and another new line. That seems to work okay. But it still gives us nothing back. Oh, it's arguing its way around. Should it be that way round? Yes, it should. No, it shouldn't. Just end of input. Do I need to consume the end of input? I wouldn't have thought so. No. So imports again, and we can say I comes from read file and day 13 slash test input. Not that. I thought that was the straight version of read file, but let's do that. Okay, so we have some input. Oh, there's no new line at the end. Ah, okay, that's going to catch me out. Is it some end of line? Not quite what I want. I just want optional end of line. That works? Maybe it works. Reload. So import menu parsec, import part 1, read the file, and then we can say parse test, parse pairs, and then the input string. Okay, that might have been enough to fix it. Right, and then things. Okay, cool. So now we can just 56 minutes to parse the file, but now we can try evaluating it. So what are we looking for? We want the number of matching. Well, no, it's not quite that. The indices of the pairs in the right order. Okay. One, two, 4, and 6. So pair 1 is the first input. Okay. So let's try and write the rules for evaluating it. So we can say, let's call it correct order rather than right. Correct order takes a pair of list of lists and it returns a Boolean. Okay. So they're both empty. We must be fine. Maybe we're not fine. Let's start with the cases they had. So the real input file has a new line at the end, so I could just add a new line to it. Yeah, I've done it now. I have my optional end of line. It seems to be working. It must just have been a copy and paste error. Correct order, right. So the rule is, if they're both numbers, so what have we got? On the left-hand side, if we have a number, because that can be in the list, x followed by lefts let's look at a pair. So we'll just go correct order from a pair. That's why I had these brackets. Okay. And then on the right hand side, if we have a number plus y followed by rights, then what do? We return x is less than y. Is that right? What are the rules? So if both values are integers, the lower integer should come first. So the left is lower than the right. If the left is higher than the right, then it's wrong. Otherwise, we continue. Okay. So if left is right. If left is smaller than y, then we're true. If x is greater than y, then it's false. Otherwise, we want to check the correct order. Those are both the same. Then we look at L's and lefts and rights. Okay. Tell me these brackets, it's correct in that. So that's the case where they're both numbers. So we can just call it compare numbers. So this takes what's this going to take? It's going to take a number. Technically, it takes a list to a list. Okay, that's what's going to be quite annoying. Let's take the integer out of there so we can take an int, two ints, and return a bool. X and Y, and let's grab these guards. That's no good because we need the rest of the string. Okay, I'm just going to leave it in line here. This is going to get quite long. So if we're comparing two numbers, everything is fine. Otherwise, we'll have a list and it's got left and the rest of lefts. We've got another list which contains right and the rest of rights. And I think we compare what we're saying. If both values are lists, compare the first value of each list, then the second, and so on. If the left list runs out of items first, the items are in the right order. If the right runs out of items first, the items are not in the right order. Okay, let's do that case. So if we have an empty list, but we have something on the right hand side, then we know it's false. They're not in the right order. So this is the, no wait, so that's the left running out first. If the left runs out of items first, then the inputs are in the right order. Okay, left runs out of items first in the right order. And if we have a non-empty list, oops, and an empty list on the right, so the right run out of stuff first, then it's false. Otherwise, we have a list with L and Ls, and a list of R and Rs, then we want to make sure that the items themselves are in the correct order. So this is going to be L and R, and the remaining things are in the correct order as well. L's and R's. Then we got some more cases. I'm going to relistify these. So if they're both empty, they're both empty. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. Okay, that's listifying the thing. So we're going to say if this is the thing where we compare this item to that item. So we compare the first of each list and the second and so on. I actually think this is slightly wrong. So we want to say we need this special case where one of the things is an integer and the other one is a list. It says exactly one value is an integer. So what example is that? So if we've got the list, blah, 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 and the integer 2, then we convert to the list 2. So let's do that case, I think. So correct order, oops, correct order where we have a list on one side, this is else, and we have a number on the right hand side. Then we try it again with else, but a list containing the number y. Underlining is really annoying. Okay, so correct order. I'm just going to capture this as L at some list and R at, oops, R at some number. And then we compare L to a list containing R. Okay, and we don't care what the number is. Get rid of some of these underscore, these variables we're not using anymore. You just care if they're lists, not what they are. Okay, so what are we left with? We've done the case where they're both numbers, we just did comparison. This is incomplete. And actually, this is not a valid list. It is a valid list. Right, it shouldn't be a valid list. So my type is slightly wrong. So this is either goodness, it's either going to be a list containing lists. I need to think of some new names here. Or it's a number containing an int. And this, we can just say type of list is a list of list items. Okay, so these are now going to return list items. And this should be a list. No. Put it back to where it was. I'll not try and fix my type because I'm running out of time. Okay. It kind of makes sense actually because we want to look at the contents of the list. So we might end up just passing in two numbers. Okay, so if that's not the case, so we've got two numbers and this guard does not match. Then we just want to run through it, don't we? So only if they're the same that we continue checking. See, so we think about this. So if two numbers are the same, then we continue checking. These are actually irrelevant, these ones at the end, I think. I think we stop at the point where the low integer comes first. Because as soon as we see that case, then the input's in the right order. So we've got two numbers in the right order if the left is lower than the right. Left is lower than the right. If we have a list, if we run out of inputs, so if the left list runs out of items first, the input's in the right order. So we run out of lists on the left, then we're in the right order. If the right list runs out of items first, they're not in the right order. The right runs out of items first. Then we're not in the right order. If we have exactly one value, if exactly one value is an integer, so there must be a list by definition. So we have a list and a number. Then we try it again. So we convert the number to a list and then do the comparison. I'm missing one case for that. Sorry, this one. So that's if the right hand side is a number, but we need to flip them around a bit. So if the left is a number and the right is a list, then it's going to be list containing the single L and then just R. Okay, so none of these have matched. I think the only case left is they're both integers and they're the same, or they're both lists. No, if they're both lists, then this is the case. So if they're both lists, we take the first item off each list and compare them. We'll come through and hit these things, and then we take the rest of the things and we also compare those. Okay, so I think the only case should be we have two numbers and they are the same. Now, what am I missing? Tell me what I'm missing here. Oh, both lists are empty. If they're identical, it's actually undefined here, I think. So, two empty lists. lists are empty. Okay, so now we have this case when we have the numbers and they must be the same. So I think I'm going to match this explicitly because that only makes sense if there's something else. So what I think I want to do is say we have a list containing a number. Oops, sorry. A list containing the number L and some L's, some remaining L's, and another list containing the number R and some other R's. Actually, because we're always comparing lists of things. No, we're not always comparing lists of things, are we? We can make it so we are. No, because going to the type, we can still pass in just a number. No, don't leave it there. Okay, so we got lists on both sides. They both contain numbers. We need to put the guard in place. So we're going to say where L is equal to R, then we just check everything else. Okay, and then here we can just have some pair, and we can just have an error case because I don't think we should hit this. So cannot compare. And we just have a look at the pair. Oops. Okay. So we should be able to take our pairs and turn them into a list of correct orders. So we got our list of pairs at this point, and then we should be able to map the compare lists. What do they call it? I put it a second ago, I already forgot what it's called. Compare correct order. Correct order over the left of these things, sorry, the right of these things. And we should get something like true, true, false, true, true, something like that. I can't remember what the exact thing was. I don't think it's going to work. No, can't compare empty lists. So if I've got empty lists, it means that I'm recursively calling this thing and I got to the end. So we'll just say this is true. We don't have input. We're probably fine. Probably. True, false, false, true, false. This does not seem to match up. So pair 1, correct order. Pair 2, correct order. Doesn't that second to last example have a winner? Second to last example. Which one is the second to last example? Because I've moved it around a bit. Is it this one you're talking about? I have to wait now for that. Oh, on the AOC page, the second to last example have a winner. This one. This has a winner because we have a list containing an empty list and an empty list. They're not the same thing. So for me, that should hit this case. No, sorry, this case. So we have a list containing something. In this case, it happens to be an empty list, but we don't care. I think it's list, list, empty list, empty list. So I think it comes out as list, list, empty list, colon, empty list. I think that's what it looks like. So it matches this pattern. And we're comparing it with just this thing. So I think that one matches okay. Let me just take the... Oh, actually, what answers did I get? It thought the first two were the same. Oh, sorry, we're in the correct order, so that's okay. Hopefully we get to here. Right, what have we got here? We've got list containing 1, list containing 1. They should be the same. Then we got 2, 3, 4 versus 4. Then we should compare 2, 3, 4 to 4. What happens in this case? So if we get to 2, 3, 4, a list containing 2, 3, 4, and a list containing 4. So we've got a list containing 2, 3, 4, and a list containing 4. Hopefully we hit this case. Then we take the two things out, so the 2 and 4, and we compare them. Ooh. If that's true, then we stop. And if it's false, then we stop. Right, okay, this is wrong. Okay, so here we should say, if L is less than R, then it's true. If L is greater than R, then it's false. But if they're equal, then we compare the other things. Let me just get rid of that for a second. So it's the top. Okay. So now this must be a list of lists. And this must be lists as well. Then what's it going to be? We compare the thing on the left to the thing on the right. So maybe it's easier to write these cases out. So if we have two lists, then we compare the order of those things. The trouble is, like, we got, it's truthy, isn't it? It's not true and false, because you got true, false, and undecided. And if it's undecided, you want to keep processing. If it's true, you just want to stop. If it's false, you just want to stop. Okay, so is from left of go where go takes a pair of lists and returns maybe a bool. So we can start to put these back in. Mess that up a bit. Oops. Okay. And just pulling from left. And just let's throw an exception if it goes wrong. No, it's not from left. It's from just. Okay, so now it's back to just comparing numbers. So if we get the number L and the number R, if they're the same, the numbers are the same, then nothing. Okay, these are the cases we know about. Those cases are fine. Don't think this should happen, but just me. I'm hoping I take this case out because I think this case is wrong. However, here, what we can say is line laziness here. So we can say maybe so what does this mean? That's not right anyway. If we compare left and right, let's get rid of these list bits. In fact, let's just break this down a bit. So we can compare left and right. But this might come back as nothing. So if this comes back as nothing, it means we haven't made a decision yet. So we want to compare the remaining elements. And I think this is probably a nothing. It means we haven't made a decision yet. Okay. So I need to come out of the list. Well, it doesn't actually, because this will only match the list with contents. Okay. So if this comes back as nothing, then we want to compare the remaining elements. So we should be able to say, maybe go with a list of L's and a list of R's from there. So what's gone wrong? So maybe is oh, it's not maybe. Maybe we'll apply a function to it. What's the function I want? Is it I'll just get the compiler to help me, or the Langshore to help me. So we will apply ID to it. And it says, why not use from maybe? So it's saying from maybe. Cute. From maybe. Thing. Okay, trouble is from maybe is it's going to give me this back. Does maybe implement alternate? Because then you could say something like go L and R, or go these ones. That doesn't work. So I think what will happen is you get nothing, and then it'll do the right hand side. So if you say nothing, oops, or just hi, import control.alternative. No, control.applicative. .alternative. No. Google. Come on. And I would just type it in again. So the thing I'm looking for is that, and it's control. It's just in a control.applicative apparently. Didn't think that was the case, but there we go. So now I can say whatever I said before, nothing or just hi. You get just hi. Whereas if you got just bye or that, then gives you the first one. Okay, that's exactly what I wanted. So either we get these two back, but if we return nothing, then we violate the next set. True, true, false, true, false. So you got 1, 2, false, true, false, true, and then falses. Okay. So now I need to turn to numbers, get the indexes of trues. How do you get the indexes of something? So let's say we've got something, so A to bool, and we've got a list of A's, and we want to turn it into a list of ints or integer things, so it's find indices. In fact, can we just find indices of true? Element indices of true. Okay. So back up here, so we mapped the correct order. So we now have a list of things. And then we want to get the element indices. Indices. The element indices of that. It's like that. Oh, I probably don't need the brackets. Okay. Oh, I need to give it the element we're looking for, which is true. So 0, 1, 4, 5, which maps to this 1, 2, 4, and 6. So we'll just map we'll map success over that. One, 2, 4, and 6, getting there. And then you want the sum of those things. Which is 13. Okay. So I get my puzzle input. Paste it in there. Try it with this. That thinks it's 5824. Cool. Got that put right. Okay. It's getting quite late, so I'm going to stop. I'll come back and do part 2 at some point of my own. But yeah, at least we finally got there. Quite a lot of playing with parsers, and then quite a lot of playing with trying to implement those rules properly. Some fun with alternative, I guess. Yeah, I didn't notice for ages that it was not a straightforward Boolean, and I really wanted to be returning this third state, so that took a bit of time. And then alternative was quite fun. But yeah, yeah, thank you for watching along. Have a great Christmas and Happy New Year and all that stuff. And I'll see you again some point in January to pick up again, either to do more Oven of Code or maybe go back to the virtual machine I was writing prior to that. We'll see how much time I get to kind of get back in the mindset of the stuff. But anyway, thanks for watching and see you next year. Goodbye.